think we're live. Oh, there we go. All right, I think we're live now. So hi, I'm John. Today we're going to be hosting an AMA about AuditHub, which is a new product we released in order to bring automated security tools to really everyone in Web3. And so we've gotten some questions related to AuditHub that we thought it would be useful to answer. And so in order to do so, I've invited kind of the team behind AuditHub to kind of answer some of these. So today we're going to focus on kind of AuditHub as a whole, and we might do AMA sessions later to talk a bit more deeply about the integrations that we have with, finding bugs in ZK circuits and DeFi applications as well. And so today we've got Kostas, who's our CTO, to answer questions about, kind of AuditHub as a whole and the direction, and Nikos, who's our VP of product, who has been the one who's coordinating, kind of all of the work behind AuditHub. And so thank you guys for taking time to be here. And maybe we can start by having, let's say, Kostas, can you explain kind of what AuditHub is at a high level and what benefits we wanted to bring from AuditHub?
Yeah, happy to. So AuditHub and generally, our philosophy here at Paradise is that, we try to solve the problem of that in Web3 currently the security practices are kind of reactive. We're waiting until an incident happens, and then people respond, they go insane, they identify the root cause, and then they try to save as much funds as possible, post the contracts, and so on and so forth. However, we believe that security must be proactive, and instead of monitoring your transactions, which is fine, you can do it, but your commits as you develop, they require as much as attention as the on-chain transactions. And essentially, AuditHub solve this problem. So now imagine that you are a Web3 developer, and as you develop, you set a set of automated checks, and then you say when you want these checks to run. So when one of these triggers happen, AuditHub will pull in your code base, run all the checks you required. If everything goes well, it tell you, okay, you're good to go. If not, it will notify you that something is wrong, and then you can start investigating and fixing issues. So this brings a lot of benefits. First of all, it kind of instills a security principle, if you will, as you develop, and forces you to kind of clean your code and your code base as early as possible, which has a lot of benefits down the road. You have less probabilities to find severe bugs during a manual audit by a security firm, and even after that, when you deploy in your life, you have less probability of having to pay a bug bounty, and also less probability to kind of get hacked while your protocol is live. So yeah, all in all, AuditHub is kind of we view it as a paradigm shift in the Web3 space, where instead of reacting to incidents, we are proactively checking for things that can go wrong with the protocol. And AuditHub can both detect general vulnerabilities that are common in the Web3 space, but it can also be specialized to your specific protocol, and you can kind of describe checks that are specific to your code base.
Okay. Thanks for giving that introduction, Kostas. So Nikos, can you describe a little bit about how the platform kind of works. So can you take us through kind of when someone starts working with AuditHub through kind of their life cycle interacting with it?
Yes, we set up a space dedicated to any client and onboards AuditHub. AuditHub is a service that encompasses computing resources, storage resources, and security tools that can analyze the source code of projects and produce results, findings, issues. So the client onboards, we set up a space dedicated for this client. The client chooses when to submit his code to AuditHub, and then can trigger tasks using security tools that can analyze his code and produce findings. These findings are available to the clients to further analyze, and are available either via their integration with CI/CD or with a graphical user interface through a web browser. In both cases, you can see what the output is of the tools. And from the bird's eye view, this is how the system works.
Okay. So that's a bit of an overview of how AuditHub works in general, but we've also gotten some questions when we announced AuditHub about, kind of more specifically how it works, what it's targeted at, and stuff like that. And so we wanted to take this time in order to answer some of those questions. And if anyone who's listening to the stream has other questions that we haven't answered, feel free to post them and we will answer them. So one of the questions that we've gotten about AuditHub is whether or how AuditHub is able to identify and handle cross-protocol exploits. So that, at least from my interpretation, means when you're on a blockchain, you've got multiple protocols that are interacting with each other. And so how can you identify an exploit that might occur at the intersection of two protocols? So I guess, Kostas, do you want to take that?
Yeah, sure. If I understand, because the question is a little bit vague, but I think I agree with your interpretation, John, that you have kind of complex interactions within in between protocols when you are deploying things on chain. So, and I think that's kind of where AuditHub shines in kind of finding complex bugs that require multiple interactions. So there are several ways that you can handle this type of complex interactions when you set up your AuditHub security checks. So generally speaking, AuditHub kind of has a universe of things that is looking at. So if you know what are the protocols your code base is going to interact with, you can pull them in, and AuditHub can now analyze them in conjunction with your code base. So let's say you have something that interacts with Uniswap, you set up a check, and then you either run a static analyzer or a fuzzer or whatever tool you want on top of it. So our tool now will analyze both of these code bases in conjunction with one another. That's kind of the one extreme. The other extreme is let's say you don't know what are all of the protocols that your code base is going to interact with, but in general how these protocols will behave. So in such cases, you can kind of mock the behavior of these external dependencies. And then, AuditHub can still work, as before. You kind of, expect, that your dependencies will behave that way. And then, AuditHub can find, issues specific to your protocol, assuming that, your dependencies will behave as you would expect.
One thing that I would add on to that is that the tools that we've developed also are intended to kind of reason about a project conservatively. And so what that means is if there's ever a time when control flow exits the set of contracts that AuditHub is able to reason about, it reasons conservatively about the behavior of the rest of the blockchain. And so what that means is it kind of decides on or creates a worst case behavior. And it uses that worst case behavior in order to infer how someone might interact with the protocol again. And so this allows AuditHub to look at a piece of code in isolation and then kind of conjecture what other people might be able to do if they were able to control some of these external contracts. And so that means that you might get some false positives in there. And in order to refine that false positive set, like Kostas said, you can then either add in some more information about the dependencies, or the other thing that we've tried doing, or that we've done very hard, is recognize when tools can be used kind of in conjunction with each other in a very in a productive way. And so, for example, you can start with a static analyzer to get some high-level results, and then you can reason very specifically about the types of issues that you're worried about, along with the other projects that you're going to be interacting with, in order to identify these cross-protocol issues more quickly. Okay, so another question that we've received is related to how AuditHub can be used to catch zero-day vulnerabilities. So again, Kostas, I'm going to go ahead and throw this to you and ask, like, we might not know about a specific vulnerability before it happens. And so how can AuditHub go and find these vulnerabilities that maybe we don't even know about?
So yeah, like as I said earlier, like AuditHub can be customized for your protocol, but like the customizations that we can do, they are not tailored to bugs. They are tailored to kind of describing the intended behavior of your protocol. So for example, I have like a vault, and I want to ensure that nobody can steal users funds, right? So there is mechanisms and ways to describe that with AuditHub, and then the tools then pick up and they do what they're designed to do. For example, our fuzzer will go and generate millions of tests and try to exercise the contracts and interactions between the various transactions that the API exposes to users. And every time it does that, it's going to check whether the property specified within AuditHub holds. And if it doesn't hold, it's going to give you kind of the steps to reproduce the bug. So that's one way where you can have it find zero-day vulnerabilities. And then of course as you keep developing, or as the contracts are alive, you can continue testing with fuzzers and stuff like that to see if you can find something that the fuzzer hasn't discovered by now. And another thing, if you have kind of some sort of design invariants that your system must adhere to, our static analyzer also lets you kind of describe them with a special language, and then you run the static analyzer throughout your code base. And if our static analyzer detects something that violates these design invariants, it will let you know. And some design invariants might become apparent later on, and then the minute you kind of are worried that something might be violated and might create an issue, you cannot run the check on top of your code base and see if things are okay or not.
Yeah, here the configurability of the tools is key. So the ability to customize both the at least in the DeFi space, the fuzzer and the static analyzer to the project itself really helps catch those 0-day exploits, because we can customize the tools to the project itself. So we're not just looking for those common vulnerabilities and finding things before deployment even, so that they don't become 0 days. Okay, so let's pick another question. So Nikos, one question that we got was, can AuditHub map findings to risk scores and then auto-generate fixes?
AuditHub, especially the static analysis tools of AuditHub already rate the findings with the criticality level. They also, the fuzzer, on the other hand, can produce counterexamples. So if it finds something, it's critical by definition, and it can produce a counterexample that actually shows how to reproduce the problem with a specific set of transactions that can reproduce the problem. So, but generating PRs, no, that's not something that we do.
Right. So AuditHub focuses on detection, not repair.
Exactly.
Okay. You can view, you can pull all of these results into your, GitHub. It shows you what the tools kind of found, and then you can further triage it and create PRs from there. But as Nikos said, we don't currently repair them automatically.
We also offer tools in AuditHub, inside AuditHub, where that can assist you in triaging the issues by clicking around and viewing the code that produces these issues. So in an attempt to actually help with finding where the actual vulnerability is. But no, we do not touch your code.
Okay. So, all right. Kind of similar to that, in order to narrow down on AuditHub's capabilities, someone asked, will AuditHub integrate CI/CD checks and real-time alerts? So I guess Nikos or Kostas, whichever one of you would prefer to take that.
I can take that, okay. So AuditHub can integrate very well with a CI/CD infrastructure. How? We offer, so AuditHub is basically three things. It's a core that is offered as web services. It's a UI that is offered via the browser, but it's also a CLI tool that can invoke the exact same web services, along with some scripts that help in usability. So using these command line scripts, you can integrate with CI/CD and have the tools, push the code to AuditHub and have the tools run on the fresh version, and also block waiting for the tasks to finish, and use the CI/CD's host alerting mechanism to raise alerts whenever issues are found immediately.
Okay. Kostas, anything you wanted to add to that?
No, I think, Nikos described the whole thing. And one thing that might be worth mentioning is that the client is very flexible, right? You can essentially define and pick and choose what you want to run, how you want to get alerted, and define what's important for you, and then AuditHub will serve it to you when alerts arise.
Okay, great. And so just to kind of follow up on that, which integrations do you think are the most effective? What integrations with AuditHub do you think are the most important that we've added in? So I guess this is kind of a question for both of you. So Nikos, why don't we go ahead and start with you? Which of the security-related integrations are you, I guess, the proudest of, or do you think is the most useful for teams?
I think the customization of what exactly AuditHub will do for your project, that can happen via scripts in the CI/CD pipelines, and that can be run at critical points, like before a PR is merged or as soon as something is pushed. Because what runs there, what part of AuditHub runs there, it's something that the client decides, depending on the project. So it can start a fuzzing campaign, it can do some quick static analysis for the very quick pushes, for example, and then start the fuzzing analysis before a PR is merged to, that takes longer and can verify things more robustly. These are the kind of integrations that I think matter the most.
Kostas?
Yeah, so like another thing that we are particularly proud here is that we have designed the tools in such a way that they have very good interoperability with GitHub. So specifically, all of our tools essentially meet this SARI format that GitHub kind of understands, and then whenever you run your checks, you can and let's say you don't want to go to the AuditHub UI to view the issues, you're going to essentially pull all of the results, and then they will appear as code security alerts in your GitHub project. And in terms of the actual integrations that matter the most, I would say we have ZK verifiers, right? That they're already being used by production teams to check that the circuits that they generate are good to go. That's a very important kind of integration. We have integration with the static analyzers that they will create code scan issues, and that helps teams kind of catch the silly bugs, let's say early. And finally, as Nikos mentioned earlier, integrating a fuzzing campaign. That's also very, very important because it really stress tests your protocol with essentially a click of a button. You say run this campaign for that long, and check if the protocol violated something.
Okay, so I think that kind of feeds pretty naturally into another question that we've been asked, which is what is the average running time of the tools? So you mentioned Picus, which is our formal verifier. Formal verification can take a long time. Fuzzing can also take a long time. So, I guess, can you provide some more information about how long these tools generally run?
Yeah, sure. So yeah, I mean, verifiers can take a long time. Our doesn't take that long of a time. We have worked really hard to make it as fast as possible. And it's not only a verifier; it's both a static analyzer and verifier packets in one. In the sense that in order to do the verification, we use heavy formal method, formal verification techniques in conjunction with static analysis in a synergetic way. So our ZK verifier scales pretty nicely, and it has been battle tested with real world applications, from custom protocols that write their own constraints to create an application, to whole ZK VMs. So our static analyzer is also pretty fast. I mean, static analysis is kind of the fastest of the formal method techniques. And we have also used all of these tools have been battle tested internally because we use it in our security reviews. So you could expect to run it in the scale of minutes. I would say worst case, best case is seconds. And the one that might take longer, but it might take longer because you choose to, is like a fuzzing campaign, but like longer running times for fuzzing campaigns, it's not necessarily a bad thing, because like the longer a fuzzer runs, like the more state it explores, and like the more confident you are about your code base. But here I would like to say that like if there is something like wrong with like one of the specifications, usually it will be discovered relatively relatively fast in the scale of like, some minutes. Given that like the complexity is not like the complexity of the bug is not super high.
Did you mention kind of the scale of the runtime for Picus?
Yeah, sorry, no, I forgot. Yeah, it should be in the matter of minutes as well.
Okay.
Even
Do you have a specific example here?
So I think like for example, we can verify like a Ketzak circuit in like a minute or two, like depending on this how fast the machine is, like from 1 minute to 2 minutes.
Okay. All right. So since you mentioned Orca and our fuzzer, maybe another question that we should move on to, just kind of based off of that, is how does Orca differ from other, similar fuzzers like Foundry and Foundry tests specifically, or Foundry fuzz tests?
So yeah, the main difference of Orca is like what I would call its declarativeness. So in order to set up a fuzzing campaign, you don't have to introduce a lot of fuzzer specific logic into your code base. All that Orca needs is a deployment script and a set of like specifications for your protocol. So Orca specifically works with our specification language called V, where you can describe the expected behavior of your protocol, and it's expressed in this variant of like of this temporal language that like lets you describe how your protocol should behave as time progresses. So and like that's pretty much it. You have your deployment script, you have defined your specifications. Orca takes your code base, deploys it, and then starts like checking things. And also like the fact that like it allows you to kind of like check like these more temporal properties that like it kind of like describes the behavior of the system as the time passes, is also like another difference, because like if you want to do that with like a fuzzer like Foundry, you would have to kind of like essentially like guide the fuzzer to the sequence of events that you are interested in testing, and then like let the fuzzer kind of like run, or kind of like create a wrapper that kind of like exercises like which transaction to like pick next to exercise, and then like describe the whole thing as an invariant. Whereas like Orca kind of like inherently like supports like this kind of like natural paradigm of like how blockchain system works from the get-go.
Right. So basically, at a high level, with Foundry, you can specify these kind of Foundry invariant fuzzers where you just want to check an invariant at every step in time, which you can very easily do with Vanguard or with Orca. But the other thing that you can do with Orca is you can look at more complicated temporal invariants, where you can say, like, given this event happened, we want to make sure that this event never happens in the future, or something like that. And so it just becomes a lot easier to specify these temporal relationships rather than a single static relationship. And then the other thing that you can do with Foundry is you can specify fuzz tests where it will change the input values, but it makes it very difficult in order to add some sort of arbitrary interaction in between. And so the thing that Orca is very powerful at is all of the specifications it has. It can vary not only those inputs, but it also does a good job of going and trying a bunch of different interactions with your project as well. And so rather than having to say, I want you to test X, Y, and Z, you just say, I just want to make sure that, X never happens after Y happens or something like that. So these temporal relationships, which provide much more flexibility for the fuzzer to employ that randomness, to try random interactions, and to identify these kind of sequences of operations that people might not have thought about, along with, sequences of inputs that people might not have considered. Okay, so we've been going on for a little bit, or for a little while here, but there's a few more questions that I think that we probably want to hit before we sign off. And so one of them that we've gotten fairly commonly, and someone asked on YouTube, is how are AI tools different from our tools? So I guess, Kostas, do you want to take that?
Yeah, I can start, but I'm sure John will also have something to say later on. Essentially our tools and AI are kind of complementary, right? So our tools have been built on top of years of research on formal methods techniques, and what that entails is that our tools kind of come with some level of security guarantees. So depending on the tool that you are using, that means that if the tool says, for example, if the tool says that there is no bug, that means that your code base doesn't exhibit the bug that it was tested, or vice versa. If it says that there is a bug, then the bug is real. And of course, the ultimate kind of thing is verification there. That if you say the thing is verified, it is actually verified. So of course, AI tools cannot have such guarantees because they're inherently probabilistic systems. And also another thing to mention here is that if you run our tool twice, it's gonna come back with the same results. Whereas if you run AI twice, it won't come up with the same result, most probably. So yeah, in general, you can use the two in conjunction, and where AI shines, or at least right now, is kind of surfacing the exposing the surface level bugs of your system, whereas our tools kind of go deeper and understand the semantics of the language that you're using, and understand the type of check that you want to do, and they answer the question of whether this check holds or not, accurately and definitely without any probabilities in between.
Yeah, as Kostas implied, this is something that I've had a lot of conversations with people about. And so, I mean, like Kostas said, the core thing is AI. If you want to use AI in your security workflow, you should, because really security is all about, kind of doing everything that you can in order to identify bugs. But the thing that is missing in a lot of cases about security in Web3 is identifying this absence of bugs, because really when you're talking about security, finding bugs is great, but it's not really the goal, because if you keep finding bugs, that indicates that there's a problem. It indicates that you need to do more effort surfacing bugs. But really what you want to know when it comes to security is if you're safe from something. And so in addition to using techniques in order to identify bugs, which would include things like audits and AI, using AI security tools, you also need to spend time identifying things that you are safe from. And you can't do that without reasoning specifically about your project, which is something that all the tools that we've built are meant to do. They do it implicitly. So for example, you want to know that your project is safe from reentrancies. The only way that you can do that is by formally reasoning about your project in order to say there are no reentrancies. And that's exactly what our tools do. So in addition to surfacing bugs, which you should do whatever way you feel comfortable and do as much as you can, you also should really pay attention to the security guarantees that you are providing your customers, but also that you're getting when you're interacting with a specific project. And that's really why tools like this are necessary, because they bring a higher degree of certainty. So for example, when Picus says something like, I couldn't find any determinism issues in a ZK circuit, it's because they don't exist. It has formally verified that that is absent. When Vanguard goes and it runs a specific detector and it doesn't raise anything, that's because the bug is not in there. The bug that's being described that it has a detector for is absent. And that is much more powerful. It's it just provides that degree of certainty that you really want when you're launching something that anyone can interact with. Okay. But on that note, one similar thing that we are commonly asked about AuditHub is, are you integrating AI into it? And so, Kostas, I guess I'll throw this back over to you.
Yeah, sure. Happy to answer. Not yet, but we have things planned ahead of us to kind of integrate AI features in the way that makes sense for AuditHub. And there are plenty of places where AI can help with AuditHub, and some of them have been hit by the questions as well. For example, we had this question about kind of auto alerts, but for actual vulnerabilities, or prioritizing the vulnerabilities, or how we can automatically triage kind of the alerts, and kind of put forward the ones that are more critical. And this is I think where AI shines, and it's where it can be very helpful. And all of these things are kind of things that we're gonna eventually, and we're gonna start incorporating into AuditHub.
Yeah. Do you want to mention anything about the time frame here? So when we say eventually,
oh yeah. So when I say eventually, is within the next year. So beginning the beginning of next year, and throughout the next year, our hope is to kind of roll out these type of features
right,
one by one.
Right, to make sure that AI is being used safely and in a good way. Okay, so let's see. I guess before we wrap up, there's really just one more question that we have gotten from socials that we should probably deal with, which is, what does a subscription include? So Nikos, do you want to go ahead and handle that one?
Yeah, sure. So we have a multiple level of subscriptions, one of which offers DeFi specific tools. Another one offers DeFi and ZK specific tools. And in both cases, we are offering hosting storage for your source code and for artifacts produced during task execution of our tools. We also offer computing resources that are utilized by the tools to analyze your sources. There is a limit in both, but if you need to exceed that, we offer additional packages that you can purchase and utilize even more resources if needed. And we offer access to the specific tools per your subscription that will help you analyze your sources. In a nutshell, this is what we offer as subscriptions.
Okay, great. I think that's a pretty natural place for us to end. So we literally just released the beta of AuditHub. That's why we're here. So if this sounds interesting to you, right now we've got some nice incentives for anyone who's, wants to work with us in order to, kind of craft the future of AuditHub to make sure that it works for your use case. And so this includes things like having us help you set up AuditHub so that, all the tools are tailored to your project and stuff like that. And so if any of this sounds useful to you, I would encourage you to go to the AuditHub website and request a demo, and we're happy to talk and answer any more questions that we might not have answered here. But yeah, I think that pretty much ends this session. So thanks everyone who joined, and I guess we'll see you at the next one.
Thank you, John, for coordinating all this.
All right, bye.
Thank you. Bye-bye.